So, hi guys. Today we are going to talk about API security. The agenda is to understand the new battleground in API security, talk a little bit about API pen testing, what is the required mindset and concepts for pen testing for APIs, and also about hunting for the OWASP top 10 for APIs, which is a new project. I'm one of the co-leaders together with Erez from Checkmarks. And we also see real examples for API breaches. So just a few words about myself. My name is SHKEDY. I'm the head of research at Salt Security. I have 7 years of research and pen testing experience, and I have grown up with APIs. So what does it mean? I started my career back in Israel. I was a security consultant, mostly for financial, military, and government organizations. I used to be in the red team of the Israeli army. And as you can imagine, in these types of companies, I saw mostly ASPX, JSP, and SAP with the traditional concepts, like multi-page applications, on-prem, and the APIs were more like a niche component in the application, more like for B2B communication. Then I decided to leave Israel. I bought one-way tickets to the Silicon Valley in California, and I started a new episode where I'm a security consultant for startups and tier 1 companies. And I saw new technologies like Ruby on Rails, Elixir, Node.js with new concepts like single-page applications, cloud, CI/CD, and the most important part, it's all these applications deeply rely on APIs. So before we even start talking about API security, let's try to understand what is APIs and how are they different than traditional applications. So if you took a look at the traffic between the client and the server about 5 or 10 years ago, you could see something like that. The client would request some ASPX page, for example, default.aspx. Then the application server would communicate with the database in order to fetch data. The server would filter out data and render a nice and visual HTML page that would be presented to the client, to the user by the browser. So what happens today in modern applications? First of all, you have more types of clients. You can find developers that use the APIs. You can find IoT devices, mobile devices, together with modern web applications. And on the other hand, you can find more types of database, including SQL, NoSQL, Redis, and internal microservices that are used to fetch data. So today, if you take a look at the traffic between the clients and the server, you can see that the clients would ask for very specific types of data or actions from the API. And then the application server would fetch or update data from the data sources and return to the client raw data in the format of JSONs. It's very different from a traffic perspective. And if you think about it, APIs are more about the data. And I would like to say that APIs are kind of a proxy between the client and the databases. It's a very big change. So it has many implications. In the security field, there is good news and bad news. Like we like to do in Israel, I would start with the good news. The first point is many of the traditional application vulnerabilities barely exist in APIs. If we talk about reflected XSS or CSRF, many of them are solved just by the use of authorization header instead of cookie-based authentication. I mean, in model applications, it's very rare to find SQL injections because the use of ORMs environments. And if we talk about path manipulation vulnerabilities like directory traversal, many of them are solved just because companies decided to move to S3 and cloud-based storage. The second point is traffic. The traffic is very structured, so it's easier to understand and to analyze the traffic. Let's move to the bad news. So first of all, there are more entry points. The attack surface is much wider. There is more exposed data and less abstraction layers. APIs expose the underlying implementation of the application. Also, modern concepts like CI/CD and the fact that you have so many types of clients, it makes it really hard to keep on track with the APIs. So all of these changes require a new mindset. If you're a pen tester and you test APIs, it requires you to understand the new battleground and to adapt yourself. So just a few words about the OWASP Top 10 for APIs project, the API project for OWASP. We are trying to define the new battleground of application security. We have a talk tomorrow. I think it's around noon, together with Erez about it's a kickoff for this project. You are more than welcome to come and to give your feedback. And the main pitfalls that we find today in API security, it's first of all access control problems, authorization problems, data filtering, and rate limiting. But from attacker's perspective, it's really important to understand that exploitation today requires a better understanding of the app, and vulnerabilities have become more logical. So what is the new mindset? First of all, you have to be more curious about the APIs and to understand the data flow. You should get to know the API better by asking questions about the traffic and the API calls. The second point, always leave the traffic. And you should win yourself of GUI. Stop using GUI in every task that you do, in every step in the pen test. Don't be afraid to generate API calls from scratch, because many times you get only the documentation of the API. So how can you be API curious? How can you be curious about the APIs? So stop being methodical. Stop looking for a SQL injection in every parameter. It's not a good approach for pen testing for APIs. And be more focused on the data flow. And you can use my methodology about the evaluation phases. It includes 3 different phases about how to evaluate the APIs. High-level evaluation, drill-down evaluation, and access control evaluation. They lead you to better understanding of the app, and it helps you to perform more efficient and faster penetration tests with better exploitation. So this is an API call from some type of ride-sharing app, and let's try to understand how can you understand the API better just from the API call. So first of all, you can understand it's REST-based because it uses JSON. You can understand that it has carpooling feature that allows you to share the ride with other riders. At the drill down evaluation, first of all, you can find that trips and users are represented by numbers, by integers, while driver and payments are represented by GUIDs, which are random strings. You should ask yourself is there more than one version of the API? Or and another very interesting point, if you take a look at JSON, you can see that the payment options, it's not just a string. It's a string inside an array. So you can assume it has some feature that supports payment splitting, just because it's inside an array. And the next step is to find this splitting feature. You should also ask yourself if does the API support SOAP as well, and just asking more and more questions about the API. What can you do at this step is to copy samples of each object so you have a better understanding of the relations between the resources in the API. And also, it's a good idea to just cause errors in the APIs. Instead of sending a number in the trips, just send like some weird combination of like letters and numbers, and to learn how the API handles errors. In the access control evaluation, you can understand there are 2 types of users in the app. The first one is drivers, and the second is riders. And also users have access to other users, which are the co-riders. You should ask yourself, first of all, if you take a look at the API response, you can see that the name of the co-rider includes the first name and the last name. You should ask yourself if the last name of the co-rider should be exposed. Or is there a difference between a co-rider that you invited from your application or just a random carpooling co-rider? Or can one user be a rider and a driver at the same time? What would happen with the access control mechanism in this case? Or does the API support cookies authorization as well? What can you do at this point is to identify the session label. The session label, it's just a term that I made up, but it's basically a generic name to describe every string that is used by the API to identify the user. It might be a session ID in the cookies, it might be authorization header, or any type of token. So after we understood that there is a new battleground and it requires a new mindset, let's talk about how can you hunt for APIs vulnerabilities. The most common vulnerability today is broken object level access control. You probably know this vulnerability as IDOR. We decided to change the name because of many reasons. I can elaborate. It's a very simple vulnerability that allows one user to access an object that should be accessed only by other users, that it should not have access to this object. So for example, you have an endpoint of download document, and this API call to this endpoint contains a document ID parameters. And if you're just a legit user, you would ask for your own documents. For example, 1002, this is a document that belongs to me. And if I change the document ID in the request, I would be able to access documents of other users. It's a very severe vulnerability. I find it in almost every API today. And why is it so severe and it's so common in APIs? Why it's the top one vulnerability? Because if you think about it, it's really hard to implement a proper access control mechanism. You should call like access control checks in objects almost in every function that you implement that access the database by using input from the client. It's a very spread out mechanism. Some tips about how to find IDORs and how to exploit them. So first of all, you should use the session label. This token or this session ID that identifies the user in the app. You can just log in as one user and have a short video that explains it. So this is the OWASP Juice Shop. It's a great app that allows you to practice API vulnerabilities. And I have two session labels. The first one is for user 1 and the second one is for user 2. I'm logged in as user 1 at the app. I'm performing some actions on the app. And then I go to filter. I found some API call. I'm not sure if you can see, but it contains an ID in the request, basket/4. And instead of trying to cause the same API call from another client after some GUI interaction, you can just duplicate the request, remove the session label, and replace it with the session label of user 2. And then you can easily compare between the two responses and to see if it's the same, the same data. It makes it really easier and faster to find IDORs. You should ask yourself if does the object have multiple representations, like GUID and numbers. And if you got some for or X error, like authorization error, you should try to enumerate more IDs. In many cases, the access control mechanisms are implemented in some weird way, and some objects are vulnerable and some objects are not. So the second vulnerability, which is kind of unique to APIs, it's mass assignment. Are you familiar with mass assignment? Who knows what is mass assignment in the audience? Okay, so it's one of the vulnerabilities I find harder to explain, but this line of code can help you to understand. Basically, it's when the developer decides to use a function that takes input from the client, like the params user, it came directly from the get parameter. And it updates an object in the database just based on this input from the client. And in many cases, it allows the user to update properties inside this object he should not have access to. And modern frameworks encourage developers to use these functions. It's really common to find them in APIs. So let's assume that we have this endpoint to update a specific video file on the API, and we found it's vulnerable to mass assignment. It means that we can update every property of this object, of this video object. So it's not so easy to understand how to exploit the mass assignment, because there are many properties that you can change in the object. And in traditional application, it was really hard to exploit mass assignment because you need some internal data about the properties and the properties names in the database. But today, in APIs, you can just find another endpoint that exposes this data about this object. In this case, it's just a video file, and you can see that this object, this endpoint, shows you that the video file has a parameter of conversion params, and it looks like a part of a shell command. And because I found this, I could exploit the mass assignment feature to cause shell injection. And as you can see, I just changed the conversion params that it's some internal property that should be used only by the API, only by the backend server, and to update the property by using the mass assignment vulnerability. You should try to exploit mass assignment with post and also with put and patch. And it's a good idea to use mass assignment to bypass other security mechanisms. A really cool example that I like to show related to APIs, it's in a situation that you have you have one application server that runs two applications. One of them is a legacy multi-page application, and the second one is a mobile application, which is a mobile app, a mobile API. And the mobile API uses the authorization header, while the legacy application uses cookie-based authentication. And the interesting part is that they share the same authentication configuration. So it means that the API supports cookie-based authentication, and it usually leads to CSRF. Because if the developers choose to implement authorization header authentication that is based on the header, they usually don't implement CSRF protections. So, okay, so we have a CSRF. Let's exploit it in order to change the user's email. So I tried to use the endpoint of API/v1/update email to update the user email and then to reset his password. But it requires me to enter the old password, which is it's sad because I couldn't exploit it. Anyhow, the endpoint of put/mobile/API/user/me that should be used just to update basic data about the user, like first name and last name, it's vulnerable to mass assignments. So it means that I can update every property of the user. So I actually can update the user email using the mass assignment. So the exploitation would be to target a victim who uses the old applications. It means that the cookie are stored in his browser to create a malicious HTML page that exploits the CSRF. And inside the CSRF payload, I can exploit the mass assignment in order to update the user's email. I can send it to the victim and change his email and reset his password. It's a very common vulnerability in APIs. It's a combination of CSRF and mass assignment, and it's a good example of how can you bypass this mechanism of enter old password in order to reset the user's password. Another vulnerability, which is very common in APIs, it's improper data filtering. The first part of this vulnerability, which is very common to see today in APIs, it's client-side data filtering. It's a very simple vulnerability. Basically, the API exposes by design sensitive data about the users that the API should not expose. So we have some mobile app. It's called Super Safe App, very promising name, and it has a feature of viewing a profile of one user. In this case, it's Bob, and you can find public data about Bob, like the fact he's a minion and his hobbies. But if you take a look at the traffic between the client and the API, you can see something very interesting. The API call to v1/user/profile/717, which is the ID of Bob, contains all the public data, like user ID and the profile picture, which is not very interesting, but also the address of Bob, which is PII. It's a very sensitive data. So what happens is the developers choose to filter the data before it's showing to the user itself. So the mobile app would filter this data before showing it the profile of Bob. It's a very bad idea to filter sensitive data in the client side. It's not a good approach from security perspective, and it's very common in APIs. How can you find this vulnerability? First of all, you should be curious about the API responses and to look for all the possible ways to access a specific resource. So let's say that we have some feature that allows users to comment on articles in the website. So if you take a look here at this endpoint, you can see that this endpoint exposes just basic data about the people who commented on this article, like first name and the content of the comment. But if you used the export feature, it allows you to export an article. You can see it returns more data, including the email of the user. So let's talk a little bit how can we expand the attack surface in APIs. So many times when you test an API, you get into a dead end and you don't really know how to proceed. So the first thing that you can do is to find more endpoints, how to communicate with the APIs, more entry points. And I would like to say that there are two types of endpoints. There are wet endpoints. It means that you have an active client that can communicate with the APIs. And you should find as much as possible. You should find as much as possible clients and different types of clients that communicate with the APIs in order to find more wet endpoints that you can actually see the traffic between the clients and the API. You can use different clients for the API, mobile or web. And the very interesting point is many companies, large companies, many times have a different web application for mobile. So if you access the API, if you access the application from a browser on a mobile, it would be a different application. You can use old versions of the application. If we talk about APK, if you talk about Android, you can use APK Pure in order to download older versions of the Android apps, or archive.com to find all JavaScripts of the application, of the web application. And there is the second type of endpoints. I would like to call them a dry endpoint, that you can see only the documentation, and you can't really see the traffic between the clients. You don't have an active client that communicates with these endpoints, so you can assume how the input should look like. You can use tools like JSCAN, or just to scan the strings inside the APK files and the IPA files, the client's files, in order to find more dry endpoints. It's not so easy to work with dry endpoints because many times you don't really know or understand which inputs should be sent to these endpoints. But sometimes the server would return detailed errors that allows you to understand what should be sent. Also, you can look for non-documentation files like swagger.json, API docs, so application.point.waddle. And another good idea, something that you can do, is to use websites like VirusTotal and Census just to find more hosts from the same domain that run the same API. What I found in many pen tests that if two different hosts run the same API, many times they run with different configuration, or maybe with the older version. So sometimes if you use another, in the Facebook, like a few years ago, some researchers found something in Facebook that allowed them to perform brute force on the username and password of users using some beta API. Because in the beta API, they didn't implement the brute force protection. So many times APIs, hosts, like if you have some beta or QA or staging hosts that run the same API, sometimes they don't run the same security configuration or the same security mechanisms. And it would be a good idea to always look for the most niche features. So if it's the main page of the app, many times it wouldn't be vulnerable to common vulnerabilities because of bug bounties or because the developers thought about that. But developers tend to put less resources, to think less about security when it comes to some niche features. So always try to look for these niche features. And also, don't forget different protocols. It means, many times it means different implementations. So a modern application might expose SOAP, Elasticsearch, GraphQL, and WebSockets at the same time, and you should test each one of them as a different application. Don't assume that they implement the same security mechanisms. And also, this is like a short list of interesting features that tend to be vulnerable to some types of attacks, like export mechanism, user management, sub-users, or custom views of the dashboard. I would like to share with you a quick example. So let's see a quick example for a real API attack. It was one of the biggest food delivery applications, and the security team had done a pretty good job with the API. I hadn't found something interesting for a couple of days, and I was pretty sad about that. I really wanted to find something interesting. So the attack steps were to download an old version of the app, and I found a really niche feature. It was hidden deep inside the GUI. It was to update the user's phone number. It was only available in the old version of the app. And this process includes two steps. The first one was to get confirmation code for the new number. It was vulnerable to IDOR, sorry. And then using this code, I should verify with this endpoint, the verify update number, I should have sent the confirmation code I got using the SMS token in order to complete the process. So it was an interesting vector, but I couldn't really update another user's phone number because of the second step that wasn't vulnerable to IDOR. So after some research, I found something very interesting. The confirmation token I got in the SMS, from the SMS could be used for the login mechanism. I found some endpoint that allowed me to log in with the code, with an SMS code, and I could use the code from the first feature to log in with the second feature. But the bad news is that the endpoint verifies the device GUID. It was some header that was sent together with every API call. It means there is double verification. I couldn't really exploit it. But if you think about it, it sounds like a feature that might have been added recently to the API. So what I did, I just scanned all the endpoints with the same URL structure. I just changed all the, like from v0.0 to 5.0, sorry, in the URL. And after I ran the script, I found that version 2.7 was exposed and didn't verify the device ID. It was a very simple way to bypass this mechanism, and it means full account takeover for this food delivery app. This is the last slide, and I just like to, I think it's a good example how API's vulnerabilities require you to understand the logic of the API. It's not so easy to find like good API vulnerabilities, but if you use the attack vectors, like the non-attack vectors for APIs, and you understand the logic of the API, you can find very interesting stuff. Any questions? Any thoughts?